In this lesson, you'll learn how to interpret the duration cost scatter plot, also known as the joint confidence level chart. This plot helps you visualize in a single diagram the relationship between two of the most critical values in any project: the project's completion date and its total cost. So what does the scatter plot show? The plot compares two variables. On the x-axis, the horizontal one, the project completion date or duration. On the y-axis, so this chart allows us to analyze how both variables behave simultaneously. So there's four possible scenarios. When analyzing the scatter plot, the simulation results fall into four possible quadrants: scenario, time, and budget-wise. Total success would be on time and under budget. Cost overrun, on time, over budget. Delay controlled, late, but under budget. And the worst case scenario, late and over budget. Now, the scatter sheet displays this chart with the data points generated by each iteration, 5,000 iterations. Each dot represents a possible project scenario based on completion date and cost. These data points are compared against two reference values found in cells B5 and B6. B5 contains the target completion date and B6 the target budget. By default, these values correspond to a deterministic scenario. For example, July 25th, 2026 as the expected finish date and 23,000. So how do we interpret the results? Each of the 5,000 data points will fall into one. Therefore, an example of simulated scenario distribution: 10% of the cases on time and over budget, 9% of the cases. This tells us that in this case, more than 2/3 of the time, the project ends up late and over budget. So what does this mean? It shows that the deterministic scenario, July 25th, 2026, and $23,000 as a budget, is too optimistic. In real life, it is unlikely to happen due to the uncertainty in task durations and costs. So we need to get more realistic targets. So we could use percentiles to set new goals. A common strategy would be to use the 80th percentile to set targets with a higher chance of success. So the suggested new targets would be a completion date of July 31st, 2026, the 80th percentile, and a budget of $24,680, the corresponding 80th percentile. These values are entered in cells B5 and B6 in the parameters sheet. So after applying the new goals and updating the chart, the probability of success meeting both targets, time and cost, increases to 68% probability of success. This means that if we use more realistic percentiles, 2 out of 3 times the project will succeed. So why isn't it exactly 80%? Even though both values, time and cost, are set at the 80th percentile, the combined probability drops to 68% because it is harder to meet two conditions simultaneously. And the combined probability reflects the conditional intersection of two events. So we conclude: using the scatter plot and adjusted goals with percentiles allows us to set more realistic expectations and make better informed decisions. We haven't yet incorporated external risks into this simulation, but even so, this shows how probabilistic analysis dramatically changes the probability of project success.